Okay, so now in the next part of this series on standard deviation, we're going to look at how we can actually calculate a probability using a z-table, which is a function of the standard normal distribution, which we learned in the last unit. So we know that this player has averaged 10 points a game. And now we want to pick a number that would give us some sort of probability. So let's say we want to know how often, what's the probability of the player scoring 15 points or less. And the way we would do it is with a z-table. So the z-table is simple. You know, the z-score is simple. We're basically going to take the number we're looking for, which would be 15 in this case, minus the average, which is 10, over the standard deviation, which if you recall is 4.082. So what are we really doing? We're asking ourselves, how many standard deviations are we over the mean for the data point that we're looking for, right? 15 minus 10 over standard deviation, which is sigma. So right here, I already worked out the numbers on Excel, and it's 15 minus 10 divided by 4.082. And back in the day, before we had the magic of Excel, we used a z-table. So if I go to 1.22, somewhere between, it's going to be somewhere between 1.2 and between 0.02 and 3 to get 0.82. So it's going to be kind of more toward 89%. It's going to be right around 89%. So what this is telling me is that 89% of the time, the player will score 15 points or less. And if I subtract 1 from 89%, which would be, going back to our table, somewhere over here, then it's about 11% that the player would score 15 points or more. So that's all you need to do. And if you don't want to use a z-table and you want to come into modern times, you just go to norm.s.distribution, which is a function we use for the Black-Scholes model, by the way. Plug in your z-score, say true, because you want to know the cumulative probability function, and you're going to get the exact number, 0.88969. That's going to calculate it for you exactly. So, you know, that's all you need to do. Now, let's say I want to see the probability of, let me stop that for a minute. Let's say I want to see the probability that the player will score exactly 10 points, which is the average. Well, then I'm going to get a 0 z-score. And obviously, intuitively, it's going to be 50%. 50% chance that they score 10, 50% more. And if their average is 10, well, we'd be right here. So 50% of the probability of doing better would be this way. 50% of the probability of them doing worse would be this way. What about the idea that the player scores at least 5 points? No, we're going to take that out. And now we're going to be in a negative z-table. Let me just get that here. And it's going to be a negative, which is minus 1.22. And I've got that too. So we go to the minus the negative z-table, which is minus 1.22. And it'd be, that would be that that we have an 11% chance that they score less than 2 points and almost an 89% chance that they would score more than 2 points. And if I want to plug that up here, minus 1.22489, I'll just put a little negative there. That would work out for me, 11%. So that's all you need to do to apply these z-scores. You just need to find the number you're looking for, less the mean, over sigma, use the z-table, or in fact, just use the Excel spreadsheet, and you would get the probability that you would get at least that score. And then if you want to know the probability that you would get more, just subtract 1 from there. So I hope this was self-explanatory. There are the z-tables. Again, for my classes, if you want, I can send you the spreadsheet, but that really kind of wraps it up. So thank you.